clustering, basically density-based clustering for geospatial analysis, specifically crime hotspots. So basically the problem is that crime hotspots form non-conventional, non-linear, and or non-circular shapes that K-means clustering usually detects. And the thing is, it doesn't account for density. It can't find true hotspots, and usually clusters form by density in areas. So that's why this is a poor. Is why density-based scanning or density-based clustering is a lot better than the traditional methods. The limitations are that it cannot detect noise in convex cluster shapes. It does not work with street geometry. It usually assumes that the data has a uniform clusters, which most of the time isn't true. Only very rare or special cases could have that. And most importantly, it requires to set K, the number of clusters, as a hyperparameter, meaning that you have to have a lot of knowledge of your data. So most people don't have a lot of knowledge when they work with their data, and it's a lot of work to compute K versus if it's done with the algorithm itself. So this basically is the motivation for the density-based scanning or density-based clustering, which basically scans the data, the set of points, and if the distance for some 2 points, so where we have P is the representative node of or representative point of the cluster, if the distance is at most this small radius epsilon, then we consider it to be in the cluster. So groups are very closely packed together, which is why you can have a very small epsilon to be considered a cluster. And if we achieve this threshold of minimum number of samples, then we consider it to be a dense region. So we can find clusters of arbitrary shape. And this is what allows us to complete geospatial analysis a lot more efficiently and accurately. So now the concept is that basically we have n sub epsilon of P, where P is some representative node, and if the distance is at most the small radius epsilon, then we would consider it part of the cluster. So this basically returns a set of all the points. So instead of having a large number of Venn diagrams, this would allow us to view the clusters in the nonlinear shapes. And D is just a set of all points, and Q is some point in the data. And if the number of points if this function is at least the min samples, then we consider P to lie in a dense region. So this is how we would classify points. Essentially, we usually have we could label some points core points, which are basically all of the points where n eta of P is at least the min samples. So that means that we have, it's a densely packed region. The border points, if we have some threshold outside of that region, and we would consider it to be a border point if that does happen. So if it's within that range, and otherwise we just consider it to be noise. So, and these are the two conditions down here mathematically. If none of them suffice, then we consider it to be noise. So it accounts for noise a lot better than traditional algorithms do. The data set that we used for our case was the Chicago City crime data set. The features we used were basically the coordinates, the type of crime, and the time of day, and we simulated this. So we'll get to that in the code later. So our results for the k-means, or the general results, basically form a Venn diagram, multiple circular shapes, and it ignores the actual geometric layout of most of the streets, and some are misclassified, and they get merged in ways that don't actually represent how the data actually fluctuates. So it's a lot harder to interpret, and it uses this function called the distortion function. that takes two parameters, C and mu. So we have the number of clusters, so each cluster and that set the centroid of the cluster, so the representative point, and xi is basically just some point that we're testing, and we basically take the sum of squared distances. But the issue with that is that it doesn't account for density, the density of some cluster, but it essentially just tries to minimize the within cluster variance. But this also assumes that clusters are uniform and circular, which doesn't suffice in most of the cases that are in the real world. So in the density-based clustering, we basically identify the true crime hotspots because now we actually accounted for elongated nonlinear fashions of and non-circular clusters. So we automatically filter out noise, and we get meaningful clusters while still getting rid of the noise, and we can get rid of the irregular shapes from our data. So we group all the points within epsilon distance away from the centroid and sufficient density. And it's not just radius based, so we can include some point P if it's a subset of D, or if its distance is at most epsilon, and that's what we consider to be the set of all points Q. So now Ying can talk about the code that we worked on.
Yeah.